Hello and welcome to Unit 6, Part 1. My name is Mr. Bell. Today we're going to use the quadratic formula to solve quadratic equations, and we're going to use something called the discriminant to determine the number of solutions. There are actually several ways to solve quadratic functions. So far we've already been over how to solve a quadratic function by graphing. Recall that we would graph it once it was in standard form, and find the roots or find the x-intercepts. That was a way to find the solutions to that quadratic. Well, here is another very popular method for solving quadratic functions. It's called the quadratic formula, okay? And at first glance it looks really scary, but all it is, it's a formula involving three letters, A, B, and C. And we can use this formula to solve quadratic functions if we're not able to graph it for whatever reason. Now, where the A, the B, and the C come from is the standard form of a quadratic. We've been over this before in a previous lesson. You need your ax squared term, your bx, and your c to both be on one side of the equation and 0 on the other. This is an example of standard form, and when it's in this form, I can easily identify what my A will be, what the B will be, and what the C will be. A suggestion that I have that has been successful in the past is go ahead and get in the habit of writing a parentheses everywhere there's a variable in the quadratic formula, and then we can just plug in what needs to be plugged in later on. So to find our solutions to this quadratic particular function, we're going to do negative b plus and minus, or plus or minus, the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, if you'll notice, this can be done in your calculator, except you can only do plus for the first time, and then you'll have to either type in this scenario a second time in the calculator, or you'll have to back up, delete the plus sign, and put the minus. Plus or minus means that there are possibly two solutions here. Negative b plus all the rest of this, and then negative b minus all of this. Okay? So once we had our a, b, and c from our quadratic function, I could then go back and plug in the parts in the parentheses where they need to go. On this first example, I'm going to work this out algebraically, or by hand, the entire problem. Now, for the future examples that I do, I'm going to go ahead and plug in the A, B, and C into the quadratic formula to show you what it looks like, but then I'm going to evaluate it myself using my calculator, and it might be helpful for you to do the same. So, step one is to make sure your quadratic is in standard form. Recall that standard form means my x squared term, my x term, and my constant, if there is one, are all on one side of the equal sign and zeros on the other. We've met that criteria for this one so far. Now I need to identify the a, b, and c. The a in this quadratic function is the coefficient of the x squared term. In this case, it's a negative 1. The b is the coefficient of the x term, which is a negative 7. The c is the constant, which is a negative 10. So all I've done so far is I've identified my a, my b, and my c from my quadratic function. Now, I'll set up my quadratic formula template so that we can plug in the parts. The solutions, or x-intercepts, are negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And now I'm going to go back in and plug the parts where they're supposed to go. Negative b would be a negative 7 in this spot, plus or minus the square root of b squared, so I'll plug in a negative 7 here. 4 times a, which is a negative 1, times c, which is a negative 10, all divided by 2 times a, which is a negative 1. Now I'll begin simplifying this. So negative b, which is a negative 7, the two negatives there makes that a positive 7, plus or minus square root of negative 7 squared would give me a positive 49, and negative 4 times negative 1 is a positive 4, Positive 4 times negative 10 would give me a negative 40, all divided by 2 times negative 1, which is a negative 2. Continuing to simplify, I have 7 plus or minus the square root of 49 minus 40 is 9, all divided by negative 2. Moving on, 7 plus or minus the square root of 9 is 3. We've taken care of both possibilities with this plus or minus here. So the square root of 9 being 3 means I'm going to have 7 plus or minus 3 all divided by negative 2. And now's where I'll get my two solutions. One of them is 7 plus 3, which is 10 divided by negative 2. The other one is 7 minus 3, which is 4 divided by negative 2. And our final two solutions are negative 5 and negative 2. These are the solutions, the roots, the zeros, the x-intercepts of this quadratic function using algebra. On example 2, I'll go through the steps of setting it up, plug it into the quadratic formula, but then I'm going to evaluate with my calculator. So for step 1, to identify the a, b, and c, I need my quadratic in standard form. This one is not in standard form to begin with, so I'm going to need to move this negative 5 to the left side of the equation in order to get it in standard form. We do that using the mathematical operation to cancel a minus 5 or a negative 5. We need to add 5. Negative 5 plus 5 is 0, which is what I want on the right side of my quadratic function. If I add 5 to the left side, I need to add 5 to the right side. There is no other like term with that 5, so I'm going to write my x squared plus 3x plus 5 equal to 0. Now my quadratic's in standard form. Let's identify our a, b, and c. In this case, our coefficient of the x squared term, our a, is a 1. Remember, in front of the x squared term is your a. In this case, there's understood 1. The b is in front of the x term, which is a 3. And the c is the constant, which is a positive 5, not a negative 5. Now I'll set up my template for my quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And let's plug in the parts where they're supposed to go. The b term is 3, so negative b, I'll plug in a 3 here. I'll also plug in a b in the plus or minus square root of b squared, which is also 3, minus 4 times a, our a was 1, times c, our c was 5, all divided by 2 times a, which was 2 times 1. Now that I've got it set up, I'm going to use my calculator to evaluate my quadratic formula here. When I began to input this quadratic function in my calculator, the result said no real solutions. That means this quadratic, if we graphed it, would never cross the x-axis, and later on when we talk about the discriminant, this will make more sense, but under this square root part of our function, we wind up with a negative value, and at this point in algebra, we can't take the square root of negative numbers without involving something called imaginary numbers. So at this point, there are solutions, but they're imaginary. We'll talk more about that later on. There are no real solutions to this quadratic function. Example 3 is not in standard form at the moment, so I'm going to go ahead and do some rearranging. I'm going to cancel this negative 4x from the right side by adding 4x. I'm also going to cancel the negative 4 by adding 4 to the right side. If I add 4x and add 4 to the right side, I need to add 4x and add 4 to the left side of my equation, in which case there are no like terms to combine. My quadratic function in standard form is x squared plus 4x plus 4 is equal to 0. Now I'm able to identify my a, which is 1, my b, which is 4, and my c, which is also 4. And I'll set up my template for the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now I'll plug in the components. My b is a 4, my a is a 1, and my c is a 4. Now I'll use my calculator to evaluate this quadratic function. The first result, when I did -4 plus the square root, I got a solution of -2. Now I need to go back to my calculator again and be sure to change the plus sign to the minus to get my second solution. In this example, I also got -2 as the second solution. That means this quadratic function only has one root or one real solution, and it is -2. An example of this would be a quadratic function that only touches the x-axis one time at the value of -2. Recall from these three examples that there can be two solutions, there can be no solutions, there can be one solution to quadratic functions, and later on you'll learn about imaginary solutions or complex solutions, but for now these are the three we're going to focus on. The last part of this video involves using the discriminant to determine the number of solutions. Now, you've already kind of learned this in the previous part of this lesson. The quadratic formula, the discriminant component of the quadratic formula is just the part up underneath the square root symbol. So the formula for finding the discriminant is just the b squared minus 4 times a times c component of the quadratic formula. When you evaluate this expression, when you identify your a, b, and c and you plug it in and you have the value of the discriminant, here's how it helps. If your result of the discriminant, if your b squared minus 4 times a times c is a positive number, that means you're going to have two real solutions. If the value of your discriminant is a 0, you will have one solution. If the value of your discriminant is a negative number, you will have no real solutions. All right, take a look at this example. Let's start by identifying our A, which is 1, our B, which is 7, and our C, which is 10. And let's plug them into that discriminant formula, figure out how many solutions there should be. B squared minus 4 times A times C. My B was 7, my A was 1, and my C was 10. And when I evaluate this expression, I get a result of 9. And since 9 is a positive number, that means this quadratic will have two solutions. Next example, let's identify our A is 1, our B is 3, and our C is 5. And let's evaluate using the discriminant formula, which is b squared minus 4 times a times c. The b was 3, the a was 1, and the c was 5, giving us a result of -11. And recall that if our discriminant is negative, we will have no real solutions. Our last example needs to be in standard form first, so I will add 4 to both sides of my equation, giving me x squared plus 4x plus 4 is equal to 0. I can now identify my A is 1, my B is 4, and my C is also 4. Plugging into that discriminant, the B is 4, the A is 1, and the C is 4, giving me a result of 0. And recall that if my discriminant is 0, that means I'm going to have one solution to my quadratic function. All right, I know this was a lot, but thank you for watching, and I hope it helps.